Welcome to DevSecOps course tutorial. So we are going to get introduced to introduction to DevSecOps. DevSecOps in full is simply development, security, operation. So in this course, this part of introduction, we are going to explore fundamental of DevSecOps, including its methodology, benefit, its life cycle. I'm going to look at the key principle for DevSecOps. We're also going to look at the practices as well as the challenges and the common misconception uh, in DevSecOps. So we are going to get started. I'm going to use a tryhackme platform to for this module, and we are going to look at the introduction part. So tryhackme is a security platform uh, for those getting started and those who have been into security. So yeah, this is what I'm going to use. So in this lab, I will introduce you to different styles of software development and evolution throughout the year. So make sure you understand how things have been improved over the years and the impact in the security industry. So our objective here, we are going to look at the history behind the software development practices and how they have evolved over the years. You're also going to look at the importance of this field and concept of what makes DevSecOps. So DevSecOps culture and as a discipline. So the learning path, we get introduced to introduction. We look at the security of the pipeline, security in the pipeline, and then infrastructure as code. So I'm ready to start. So the history. Uh, okay, since it's an inception, developer operations has become a significant influence in a modern software development, deployment, and operation. But where did the team came from? So let's look at the history of DevOps. So a long time ago, there was a waterfall in a galaxy far, far away. That is it. So we're just going to look at the waterfall model to understand the history of the DevOps. So this is the name given to how project management was approached back in the days of in the 70s. So the circle constituted and relied a hierarchy where every member had a specific responsibility. For example, system admin worked tirelessly to keep everything running smoothly and flowed. Developer build and add as many features as possible. And finally, quality assurance tests the system functionality, ensuring everything works as expected. If anything troubles the server or something needs deployment, system admins will jump on it. If it's a code problem, the devs will put out the fire. If there is anything to do with the testing functionality and feedback, quality assurance teams will take care of it. But what if there is a flaw, a bug? Who fix it? This situation lead to many blame games and passing the baton around the created friction. Things will get backlogged and symbiosis between the teams and uh, end up not working anymore. As the number of customers' expectation grew, features and new release increased. Responsibility and task would end up being an accumulative giant mess. Bugs and security flaws were backlogged, plenty of the unresolved, and more release schedule which would not be stable and messy. So excessive noise and pressure lead to disrupt, communication gaps, and friction between the teams. This popular problem solving strategy and the system became a root cause of ineffectiveness and flexibility. That is the waterfall model. And in waterfall model, yeah, you're just going first to look at the analysis, the design, implementation, the testing, and the maintenance. Let's look at another history. It's called the agile model. So with challenges team were facing with the waterfall model, a business started developing ways that allowed more flexibility and adaptability somewhere in early 2000. So the agile methodology was coined. Soon a manifesto was released, Agile Manifesto, emphasizing four values of agile development. The first value was individual and interaction over a process and tools. Another one was working software over comprehensive documentation. Other one was customer collaboration over a contract negotiation, then responding to challenges versus following a plan. So companies now value team collaboration and rely on self-organizing team, focusing on client and plenty of rooms for change and flexibility. Yeah, but again, something was still missing. Something was still missing. And now in 2008, a conversation between Andrew Clay and Patrick Devops led to something quite revolutionary. While discussing the drawbacks of Agile, DevOps was born, and after an event in Belgium following a year called DevOps Day, DevOps became the next buzzword and its popularity increased. So DevOps is quite different from the previous methodology because DevOps is quite different from the previous methodology because it focuses on driving cultural change to increase its efficiency. It does this by uniting the magic of all teams working on a project, using integration and automation. With these ingredients, you get a cross integration across all the departments. So quality assurance plus system admins plus developers, for example, ensuring developer can now be involved in deployment and system admin can now write a script. Quality assurance can figure out how to fix flaws versus constantly testing for the functionality by introducing automation and integration of system. So these engineers can now have the same visibility at all times and interact accordingly. We will dive more into how DevOps does in the later module as we talk about pipelines, automation, continuous integration, and continuous delivery. So why was DevOps important? So DevOps build a philosophy that emphasizes building trust and liaising between developers and other teams. Other teams you're talking of system admins, quality assurance. So this helps the organization align technology project to a business requirement, increasing the impact and the value of business as project become more efficient and prioritized accordingly. Changes rolled out are usual small and reversible, visible to all teams. This ensures better contribution and communication that helps with the pace and increased competence when delivering work. In summary, we are saying that thanks to the advent of DevOps, today's in today's deployment infrastructure, it's fully automated and operates on a self-service basis. Like developers can provide resource to public cloud without depending on IT to a professional infrastructure, which in the past led to weeks or months of delays. Also saying that continuous integration and deployment process automatically set up testing, staging, and production environment in the cloud or in the premises. They can be decommissioned, scaled, or reconfigured as needed. So another thing is the increase the infrastructure as code, which is widely used to deploy environment declaratively using tools like the Terraform and the Vagrant. So organization can now also provision containerized workloads dynamically using automated adaptive process. So this declarative approach requires that the user specify the end state of the infrastructure. For example, you're saying like deploy this machine in a running state directly into an environment, automating the configuration choice throughout the workflow. The software build it and release it with no human interaction. So the imperative or the procedural approach takes action to configure system in series of actionable steps. For example, you might declare to deploy a new version of the software and automate a series of steps to get deployment of steps. So you choose when you want to apply these changes, and at the end, by adding the get, this get could be a button to release the change, e.g. deploy change button after all the automated checks and new configuration files. Okay, so in such workflow, even a tiny problem could create a mess. Moreover, as the number of new releases increase, uh, the whole matter may turn into disastrous. This could surely go out of hand with an issue still unresolved and plenty of features scheduled to be released. So you can learn more about DevOps in a room called the appnox.com under blog history of DevOps and no more. So that was a brief introduction. So you can try answer some of these questions, like what methodology relies on self-organizing team that focus on the constructive and collaboration. You're saying, yeah, we looked at the waterfall model, the agile model, and the DevOps. So you can try, maybe for example, sorry, why is this thing misbehaving? You can look at the int rhymes with the grandchild. Maybe we can try and answer something, maybe like DevOps, try press enter. That is agile methodology. You can also look at something like what methodology relies on automation and integration to drive cultural change and unite teams. You can look at something like DevOps. They are just easy questions. What does DevOps emphasize? So you can also just come here and look what DevOps emphasizes. DevOps builds a philosophy that emphasizes building trust and better liaison. So you can say that saying they're talking of building trust. These are just query tests to test what you have understand. So maybe what does DevOps emphasize? You can say something like building trust and check if it's right. What traditional approach on project management led to mistrust and poor communication? You can try and say maybe waterfall. So that is it. You can't just write an answer. So let's look at something called the infinite loop. So in the previous task, we learned about different software development styles throughout the years and how this played a big part in the inception of DevOps. So in this part, we are going to introduce you to the key concepts, tools, and how all work together. So you're going first to start by how DevOps. Just a minute. We're going to start on how DevOps works, and they're saying like DevOps is visualized as an infinite loop, describing all the compromising phases. Like maybe we start maybe with the building. Okay, we can start with the plan, we come to the code, we build, we test, we release, we deploy, we operate, we monitor, and so on. So it's kind of more of an infinite loop, and following the infinite loop of the DevOps diagram. So let's expand on some of the DevOps tool process that we look at it as we follow the DevSecOps pathway and how they help an organization. So We are going to look first at something called the CI and the CD. So in the previous task, we mentioned that continuous integration and continuous deployment deals with the frequent merging of code and adding testing in automated manner to perform checks as new code is pushed and merged. So we test code as we push and merge. So thanks to the new dynamic and routine in deployment, which makes the forum of a minor code changes and systematically routinely. So this is to change the dynamic. The CI and the CD helps to detect bugs early and decreases the effort of maintaining modular code massively, which introduces a reliable rollback and versions. Another thing that you are going to look is something called infrastructure as a code. We'll look this one in the later module. So it's just a way to manage and provision infrastructure through code and automation. Thanks to this approach, so we can reuse code to use to deploy infrastructure, for example, as saying of cloud instances, which help in consistent resource creation and management. Standard tools for infrastructure of code are something like the Terraform, the Vagrant. So we will use these tools further in the pathway as we experiment with the ESC security. Another thing we are going to look at it is the configuration management. In the later module still we'll look at the difference between infrastructure as code and configuration management. And in here we are saying that is the state of infrastructure is managed and constantly applied changes effectively, making it more maintainable. So also we say thanks to this, because it saves us a lot of time and more visibility into how infrastructure is configured. Another thing is the orchestration. So orchestration is an automation workflow. It helps to achieve stability. For example, by automating the planning resource, we will have the fast response when there is a problem. Another thing is monitoring. Focuses on collecting data about performance and stability, services and infrastructure. This enables faster recovery, helps with the cross-team visibility, provides more data to analyze for better root cause analysis, and also generate and automate responders. Mentioned earlier, another one is the micro microservices as an indirect that breaks an application into many small services. So this has several benefits like flexibility if there is anything to scale, reduce complexity, and more option for choosing technology across microservices. So we will look at this in more detail in the DevSecOps pathway. You can decide to look at this one, like which helps in adding testing and automated manner and deals with the frequent merging of code. So here we can talk of something like the CI and the CD. Okay, that is the answer. I think my net is slow. So what process focus on collecting data to analyze the performance and stability. You can look at what process you can condition workflow. It helps in stability by automating the planning. You can look at something like orchestration. What is the way to provisions throughout the reusable and consistent piece of code? So you can look at all those ones. So let's look at another small module called shifting left. So shifting left, introduction, like you're saying, like security can also be easily integrated because of its visibility and flexibility. And DevOps introduces. So you might have heard of the concept of shifting left. So this means that the DevOps teams focus on installing security from the earliest stage in the development lifecycle and introducing more collaborative culture between deployment and security. Since security can now be introduced in early risk, so Risks are reduced massively. In the past, you will find out about security flaws and bugs in the very large stage, even in production. These are leading to stress, rollbacks, and economic losses. So integrating code analysis and automated tests earlier in the process can now identify this security in the flow during the early development. Um, so shifting left, in the past, security testing was implemented, and at the end of security life cycle, uh, as the industry evolved and security functions were introduced, security teams will perform various analyses and security testing in the final stage of the life cycle. So depending on the result of security testing, it will either permit the application to proceed for deployment into production, or reject the application and pass it back to developers for remediating the flaws identified. So this results in long day in development and friction between teams. So implementing security features during all these stages of the development life cycle, rather than at the end of the life cycle, will ensure a software is designed with security best practices in. By detecting security flaws in early development, remediation costs are lower, and there will be no need to roll back changes as they are being addressed on time. So this has reduced the cost, building trust, and improved the security and the quality of the product. So why are we shifting left and not right? So back in the days, before, the agile developer would request an infrastructure from an IT uh, to receive servers weeks or months later. Nowadays, this provisioning of infrastructure in the cloud is automated. This shift has improved development productivity and speed. However, this increased velocity can also spark security concern and lead to flaws that can go unnoticed. So you can look at something, how you're shifting left: a plan, a DevOps test, deployment, and monitoring analysis. So the shift left approach ensures that these flaws are caught early by introducing process from the start. In this pest environment, post-development security reviews, a new software version or analysis, or cloud infrastructure configuration become a bottleneck. So even when the problems are discovered, there is not enough time to remediate these before the next version or feature is introduced. So to keep up with these customer needs, they need a fast-paced environment for scaling and growth. Security is at risk of being left behind. Instilling security in the beginning and adapting security testing to become flexible and adapt to the development lifecycle environment. Lifecycle increases the chance of addressing this promptly. So the development approach is shifting in the DevOps and can be referred as DevSecOps. So with the DevSecOps, security gets introduced in the early development cycle, and this minimizes the risk massively. Integrating code analysis tools and automated tests early in the process uh, can lead to better identification and elimination of security loopholes. And as the software gets to deployment stage, everything works smoothly as anticipated. So security, it's not an add-on, it's must-have design feature. Blending security in DevOps would enhance the impact of DevOps and eliminate a lot of bottlenecks that could arise otherwise. With rise in the frequency of cyber threats and tightening regulation, adding security to DevOps is not a choice, but now indeed an obligation. So you can decide to read more about the shifting left. You can look at what time is used to describe accounting for security in the earliest development stage. You can check back. and probably shifting left. What is the development approach where security is introduced from the early stages of development? So you can try log in to TryHackMe room and try to answer those of the question to test your knowledge. So let's look at DevSecOps Security Strikes Back. Uh, so DevSecOps is an approach that relies on heavily an obligation and a platform designing that integrates security as shared responsibility. It is a culture-driven deployment stage that normalizes security as day-to-day integration. So what is the value of this? I think that DevSecOps helps to bring down vulnerability, maximize test coverage, and intensify the automation of security framework. So this reduced risk massively, assisting organization in preventing brand reputation damage and economic loss due to the security flaws, making life easier for auditing and monitoring. So how do we implement this efficiently? Uh, we are saying culture is key. It does not work without open communication and trust. It only works with collective effort. So DevSecOps should aim to bridge the security knowledge gaps between teams for everyone to think and are accountable for security. They first need the tools and the knowledge to drive the autonomy, efficiency, and confidently. So let's look now at some of the DevSecOps challenges. One, you're talking of the security silos. So it's a common for many security teams to be left out for DevOps process and portray security separately entity where specialized people can only maintain and lead security practices. So this situation creates a silo around the security and prevent engineers from understanding the necessity of security or applying security measuring from the beginning. So this is not a scalable or flexible. Security should be supportive function to help other teams scale and practice. So without security teams being a blocker, but rather a ramp to promote secure solution and decision. So the best practices is to share responsibility across all the members instead of having a specialized security engineer. Another challenge for DevOps is lack of visibility and prioritization. How does it mean? Aim to create a culture where security and other essential application component treat security as a regular aspect of application, where developer can then focus on development with confidence about security instead of security department playing a police and a blame game. So trust should be built between the teams, and the security should promote the autonomy of teams by establishing the instilled security. Another challenges is the stringent process. So every new experiment or piece of software must go through the complicated process and verification against security compliance before being used by developers. Procedures should be flexible to account for these scenarios where a lower task should be treated differently and a higher risk task and changes are targeted for this stringent process. So developers need the environment to test a new software solution, commonly security limitation. These environments are also known as the sandbox, which are temporarily isolated environments. These environments have no connection to any internal network and have no customer data. You can do a knowledge check on that one. So let's try and see the DevOps culture. So how, okay, it simply promote the autonomy of teams where it's a large organization or a start to build in hypergrowth. The only way to not to leave security behind is promoting the autonomy of teams. This can be done by automating process that fit seamlessly with the development pipeline until security tests become another type of test, like unit testing, smoke bombs, and etc. Leading by example and promoting education like creating playbook, run books to spot this flow and fix them, understand their risk, and build confidence in engineers to make secure decisions independently. The ratio of developers, platform and infrastructure engineers and etc. won't be the same as security engineers. We must put to understand that that they can't be in every conversation. Security acts as supporting function that focuses on building and trusting and creating as much overlap and knowledge between the teams. Also look at something like visibility and transparency. For every tool being introduced or practiced, this needs to be supporting a process that provides visibility and promotes transparency to other teams. So accounts for flexibility. So you're saying thanks to understanding the empathy. As mentioned earlier, instilling security in DevOps process with visibility and transparency is not easy. There is a factor that can determine success, like the level of understanding and empathy. This means that the definition of risk for security teams is unequivocal, but for the teams, the risk can be different and just as precise for them. This doesn't only apply to risk, but on building umbrella of things. It ramifies into what they prioritize, how they work, and what they think it's important enough to leave aside a project with a tight deadline to fix bugs. There is no magic tool or process for everyone. It's essential to understand how developers or engineers work, what they know to be a risk and what they prioritize. If you know their perspective, it's easier to build a process that finds a common ground and has a high chance to work versus adding another tool that creates more noise and stressing for everyone. This understanding builds a perspective which accounts for empathy, for how uh, teams work, and builds a process that accounts for flexibility. This is a need because every situation might be different, deadlines might be different, and bandwidth can change over time. As DevSecOps engineer, suppose you took time to understand how teams honor service. In that case, that will have a security scanner and add it to a development process. Work and review priority. It will be easier to get their buy-in and demonstrate value. For example, if it's a platform team and owns an internal service but a core service, this could be a bug that disrupts the service, not a potential injection that lies behind a proxy. You will need an internal credential to exploit it. So you can tune the scanners or add triagging process that takes the question they would ask themselves. So you can read more. Uh, Maybe let's just look at the last part called the fuel trouble, the software development models. So you have something like the SEC 3 Apple X Fighter Dev, the tuber quality assurance, and other have been assigned to discover uh, minerals in nearby planet in the galaxy. So the Wato, like that is the bug. It's finding the mission by providing equipment and fuel to carry out this project. They are tasked to set a course and research this planet. So yeah, can you guess the software? So this is just a task that it's going to test your understanding for this module introduction. You can decide to view this site, just that I'm not connected to my VPN, I'm on Windows. So you can decide to gauge yourself by trying out this this task. So we have understand the DevSecOps. We have known about the benefit of DevSecOps. Uh, we have also known as we have also looked at some of the challenges. We have looked at maybe key principles and practices. We have looked at the shift left, all collaboration. We have looked at the challenges. So I'm going to do now a brief. I'm going to do probably learn. I'm going to look at the development life cycle just a little bit. So we're just going to look at this just a little bit, then I will call it over. So we're going to look probably at the SDLC. So SDLC is software development life cycle and its components. So for this room, we're just going to understand the SDLC framework, learn about the phases of SDLC, how to instill security, understand security phases and process. So what is software development life cycle? So the software development life cycle is just a set of practices that make up a framework to understand software application. So software development life cycle defines the task to perform at each software development stage. This methodology aims to improve the quality of the software and the development process to exceed a customer expectation and meet the deadlines and the cost estimate. For example, with customer demand, computing power increases, which raises software cost and developer dependency. So how does SDLC work? So the software development lifecycle provides the guidance required to create a software application. It does this by splitting this task into phases that form the software development lifecycle, standardizing the task within each phase, increasing the efficiency of the development process. Each phase divides into a granular task that can be measured and tracked. This introduces capability of monitoring to ensure projects stay on track. The aim of SDLC is to establish a repeatable process and predictable outcomes from the future project can benefit. So we have these phases, like the first phase is always planning phase. So in planning phase, it simply encompasses all aspects of project and product management. So this resource allocation, project scheduling, cost estimation, and etc. The next phase is the design and the prototyping. In design and prototyping, it establishes how software application work, like the programming languages are going to be used, the method of communication with each other. That's why we talk of the API, the architecture, and etc. Next stage, maybe we look at the, you can define the requirement. You define the requirement, it's considered part of planning to determine what the application is supposed to do and its requirement. For example, social media application will require ability to connect with friends. Another one is the software development. So software development just entails building the program, writing code and documentation. We also look at operation and maintenance. This is where engineers respond to issues of application or bugs. Another stage is now the deployment also. In this stage, application or project is made available to the user. You can decide to have a deep look about planning. You get look to the requirement definition. I've already said this. Design and prototyping. You know, when you're designing, you have to know the interface of the user, the interface between system, requirement for network, instances of database. The software development. This is where now you write code. So you divide the phase part one by looking at the planning, the requirement definition, the design prototyping, and the software development. Now on phase two, we are going to probably major look on how you are going to test your code, the test design and the development. the test environment setup, test execution, and now you're also going to look at deployment and how you are going to operate and maintain the system. You're also going to look at something at calms. Uh, mm, so CALMS, as explained in Atlas, is a framework that assesses company ability to adopt in DevSops process. So yeah, you can also look at the CALMS. CALMS stand for culture, automation, lean, and measurement sharing. Then you can also decide to look at the DevSecOps metric, something like mean. Okay, it's crucial to understand what metric engineers gather before you can advise and introduce security. As in Introduction to DevSecOps room, gaining information, ground to building perspective, and empathy is crucial for buy-in and installing security. So some of the DevSecOps key metrics, you have something like mean time production, frequency of deployment, speed of deployment, deployment agility, MTR, which stands for mean time recover. You can all look at all those, and that's where we can say that's the end of basics or simply introduction to DevSecOps, development security operation. Let's meet as we also continue to in the module 2. Let's take a break and take a cup of coffee. Thank you.